Hi, and today we are going to study the concept of linear differential equation. So when the differential equation is of the form dy by dx plus p times y is equal to q, then this equation is called as linear differential equation. And this linear differential equation is non-exact, and so here we need to calculate the integrating factor. So in this case the integrating factor is equal to e to the power integration of p dx, and the general solution is y times the integrating factor is equal to indefinite integral of q times the integrating factor dx plus c. So let's solve some example depending upon this basic concept. So our first example is x times dy by dx plus y equals to x cube. So now here we are gonna make the coefficient of dy by dx as unity. So dy by dx plus y by x is equal to x square. Now comparing this equation with the standard linear differential equation, dy by dx plus py which is equal to q. So here the integrating factor is equal to e to the power integration of p dx, which is equal to e to the power integration of 1 by x dx, which is equal to e to the power log x. This we can write x. So a general solution will be y into integrating factor is equal to indefinite integral of q into integrating factor dx plus c. So yx is equal to integration of x cube dx plus c. So yx is equal to x to the power 4 by 4 plus c. So this is the general solution of the given differential equation. Let's take another example, that is t times dx by dt plus x equals to t. So what we are going to do is we are going to make the coefficient of dx by dt as unity. So dx by dt plus x by t, which is equal to 1. Now our general linear differential equation is dy by dx plus p times y, which is equal to q. So here integrating factor is equal to e to the power integration of 1 by t dt, so which is equal to e to the power log t, which is equal to t. So our general solution will be y into integrating factor. So here we have x into integrating factor, which is equal to indefinite integral of 1 into integrating factor t dt plus c. So xt is equal to t to the power 2 by 2 plus c is the general solution for the given differential equation. Our third example is dy by dx plus 2y tan x, which is equal to sin x, and y is equal to 0 when x is equal to pi by 3. So here p is equal to 2 times tan x, and the integrating factor which will be equal to e to the power integration of 2 tan x dx, which is equal to 2 e to the power integration 2 times integration of tan x dx. So now this integration of tan x dx can be written as integration of sin x upon cos x dx. So negative integration of negative sin x upon cos x dx. So this is in the form of integration of f dash x upon f of x, which will be log of f of x. So negative log of cos x, which can be written as log of sec x. So we can write this as e to the power 2 times log of sec x. so e to the power log of sec square x. So we can write this as sec square x. So integrating factor is sec square x, and the general solution will be y into integrating factor, which will be equal to indefinite integral of q into integrating factor times dx plus c. So y into sec square x, which will be equal to integration of sin x times 1 upon cos square x dx plus c, and y times sec square x, which will be equal to integration of sin x upon cos x times 1 upon cos x dx plus c. So now we came up with the equation, which is y times sec square x, which is equal to integration of sin x upon cos x times 1 upon cos x dx plus c. And now y times sec square x, which will be equal to integration of tan x times sec x dx plus c. So y times sec square x, which will be equal to integration of tan x sec x is sec x plus c. So y is equal to sec x upon sec square x plus c upon sec square x. So y is equal to 1 upon sec x plus cos square x times c. Y is equal to cos x plus cos square x times c. So y is equal to 0 when x is equal to pi by 3, means 0 is equal to cos of 60 degrees plus cos square of 60 degrees times c. So now we are gonna draw a 30, 60, 90 triangle. So this is 30, this side is 60, and this is 90. Opposite side to 90 is 2, opposite side to 30 is 1, opposite side to 60 is root 3. So is equal to 1 by 2 plus 1 by 2 square multiplied by c. So negative 1 by 2, which is equal to 1 by 4 into c. 2 1s are, 2 2s are. So c is equal to negative 2. So the general solution for this differential equation is y is equal to cos x negative 2 times cos square x. So let's take another example. So our fourth example is x times x minus 1 dy by dx minus y, which is equal to x square multiplied by x minus 1 bracket square. So first we are going to make the coefficient of dy by dx as unity. So dy by dx minus y upon x times x minus 1, which is equal to x times x minus 1. So here, comparing with the standard linear differential equation, dy by dx plus py is equal to q. So here p is equal to negative 1 upon x times x minus 1. And now what we are going to do is, by making the use of the partial fraction, we are going to split these terms. So which is 1 by x plus 1 upon x minus 1. So this is our mother fraction and these are our child fractions. Now what value of this x will make this term infinity is 0. So put the 0 in this mother fraction excluding this term. So we'll get negative 1 upon negative 1, which is 1. So our numerator will be 1 here. And what value of x will make this child fraction as infinity is positive 1. So put positive 1 in the mother fraction excluding this term. So this will be a negative 1 upon 1, which will be negative 1. So our numerator will be negative 1. So which is 1 upon x, negative 1 upon x minus 1. So our integrating factor will be equal to e to the power integration of 1 by x negative 1 by x minus 1 times dx. So e to the power integration of 1 by x is log x minus log of x minus 1. So this will be equal to e to the power log of x divided by x minus 1, which will be equal to x upon x minus 1. So the general solution will be y into x upon x minus 1, which will be equal to integration of this will be q. So x times x minus 1 times integrating factor times dx plus c. So y times x upon x minus 1, which will be equal to integration of x square dx plus c, which will be equal to y times x upon x minus 1 equals to x to the power 3 by 3 plus c. So this is the general solution for the given differential equation. So this was all information regarding the linear differential equation, and thank you for watching this video.